Okay, Mark Coleman for Container Solutions, speaking to Luke Marsden from ClusterHQ. Welcome, Luke.
Hi, thank you. Yeah, thanks for having me.
So I first came across ClusterHQ because one of your guys, I forget his name now, came over to talk at our Docker meetup in October.
Marcus, probably?
Marcus, that's right,
Yes.
Hughes, yeah. And he was talking all about Flocker. I'm going to come back to Flocker a little bit later. Maybe you could introduce yourself a little.
Yeah, sure. So, sort of by way of introduction, I started getting interested in hosting things in about 2001 when I started a shared web hosting company with a friend of mine. Um, I was then fortunate enough to go and study computer science at Oxford, which got me thinking about things in a really distributed way. And I left that experience trying to figure out how to solve some of the big problems we had in the hosting company. And the problems were threefold. We had hardware and software going offline, meaning that I had to scramble to recover websites. We had websites getting spikes in traffic and therefore needing to be moved from shared environments to dedicated environments and back. And we had customers making mistakes and asking us to recover like a version of their website from Thursday morning or whatever. And so this was sort of 2008. And so the world was going crazy about virtualization and shared storage. But I really didn't want to put a SAN in the middle of our architecture diagram. It didn't feel right. And what's more, we couldn't afford one. So so instead, I looked around and we sort of got creative. And so back in 2008, we started building a container-based storage cluster, or let me put it a different way, a cluster for hosting containerized applications that used ZFS as a storage backend and would be continuously snapshotting and replicating the changes that got made to each of the ZFS volumes that were attached to each of the containers. And it was originally based on OpenSolaris, and then we switched to FreeBSD. So we ended up using FreeBSD jails, and each website or database would end up in its own jail and get backed onto its own ZFS volume. So we were solving storage problems for containers back in 2008. And so fast forward a few years, we built the platform up. We built it up as basically a competitor to cPanel that was clustered. And it turned out that the hosting industry was kind of having a tough time because it was being challenged a lot by sort of the big cloud providers and DigitalOcean and that sort of thing. And then Docker came along, and we realized that, hey, this Docker thing's really taking off. And what's more, we've got this sort of big stack of technology that we built that solves HA, auto scaling, failover, and all sorts of operational use cases that is going to be really useful to the Docker ecosystem. Because we saw that the big problem in the Docker ecosystem is really that as soon as you attach a volume to a container, that in order to run a stateful container like a MySQL server or a Postgres server in a Docker container, then that that container then gets stuck on that machine because you can't easily move the volume around. And so that's sort of the big problem we're trying to solve with Flocker.
Right. You've jumped way past a few of my questions there, but that's fine.
Okay.
Very smooth introduction. I wanted to ask you a little bit about when I was Googling, TweetDeck came up.
Yeah.
You were involved in TweetDeck somehow.
Yes, I worked there for a short time. I worked there. I went to work there because they were working. Their API servers were written in Twisted, and at the time I was doing a web development job. I was doing a web development job in Bristol, and the TweetDeck job came up on the Twisted mailing list, and even though it meant I'd have to commute from Bristol to London, I thought I'm going to do it because I wanted to get some real sort of operational, some real world experience with Twisted. Because at that time, we were still prototyping the early version of the previous product, which is called Hybrid Cluster, in Twisted, and it was a great opportunity for me to sort of get to know the language, well, get to know the framework a bit better.
Okay, clear. So you're now CEO at ClusterHQ, is that correct?
CTO.
CTO, okay.
Yes.
How big's the team?
So we've got 14 people,
Hmm.
and we're fairly distributed as a team. I can tell you a bit about that if you like. So,
Well, it looks like you're either in a sort of very personalized office or a bedroom right now. I'm not quite sure which.
yeah, I'm actually working from home at the moment.
Ah, right.
But yeah, the distributed team is we have a sort of headquarters in Bristol, England, and we're building up a team there. Um, and we have people, a team that was building up now in San Francisco as well, in California, where our CEO Mark Davis is based, and we also have sort of a loose group of people in Cambridge, Massachusetts, that may well form an office there eventually, and we also have one guy in Canada and another guy in Ukraine. And another guy in New York. So it's we're really sort of trying to pick up talent wherever we can find it. And I should probably say at this point that we are hiring at the moment. And yeah, if you want to check out github.com/clusterhq/hiring, then we got some job opportunities up there. And we're hiring all over Europe and North America.
So you again beat me to the hiring question, but fine, that's good. So right now, what's the goal of ClusterHQ? So you were looking at trying to solve these problems. You're talking about high availability, auto scaling. What's the actual product? Why is it so tightly coupled to Docker or containers?
Hmm. So I'll sort of zoom out a little bit to answer that question. And so if you look at the big waves of innovation in IT, I would argue that virtualization was a huge wave of innovation because it allowed one to abstract the server from the underlying storage and network infrastructure.
Hmm.
And and by being able to abstract the server or the concept of the server, it made many operational use cases much easier. So in particular, if you need to upgrade the RAM on one of your machines, you can now just move all the VMs off that hypervisor host in a VMware environment, for example. And that was that, along with a number of other use cases like HA, like sort of VMware DRS, which dynamically moves things around in response to changing load, really sort of revolutionized the operational aspects of running services. And I see the same thing happening again with containers. It's sort of a pattern repeating itself. And so if you look at containers as the new hypervisor, then what we see as our mission is sort of the ability to provide a equally brilliant operational experience to those to the operational experience you get using VMs in a sort of container specific environment, if that makes sense.
I think it does. I haven't used it yet, so I
Okay.
think I'd have to get some hands-on experience. But yeah, I mean that seems to follow.
Mm,
What I often talk about when I'm explaining Docker to people is that this separation of concerns, and I guess that
mm,
wasn't quite as clear with the move from hardware to VMs. But the idea that ops guys can really concentrate on what ops guys do now, and
mhm,
developers and ops guys who are putting together software can stick it in a container
mhm,
and let that be run wherever. But one of the biggest problems, which you touched on a little bit earlier, which every um, how do you say that? Every Docker newbie runs into this world thinking, "Wow, it solves all my problems," and then at a certain point, you hit state,
mhm.
and that's really where Flocker comes into the conversation.
Yes, that's right.
You touched on that a little bit earlier. Now, um, what's the history of Flocker? Were you struggling with problems in other ways before you came to this solution with the ZFS, or did it just kind of drop out of the sky and thought, let's build that and then iterate on it?
Sure. So the concepts behind Flocker are are effectively, I describe it sort of as a container sandwich. So if you can sandwich a set of containers that's running on a machine between a storage abstraction and a network abstraction, or sort of a storage layer and a proxy layer, if you like,
Hmm.
um, and then that allows you to move the containers around between VMs or machines or whatever, if even on bare metal, it allows you to move the containers around, and that I think is the same sort of key abstraction that was important with vMotion for virtual machines,
Right.
that enabled those operational use cases. So to answer your question, we we didn't just wake up yesterday and decide to solve these problems for Docker. We were working on it for 5 years under the guise of this previous project I mentioned called Hybrid Cluster. And despite being based on FreeBSD and targeting a different market segment, which was web hosting, we learned a lot about the problems with dealing with state in a containerized environment, and in particular the specific way in which you can coordinate network connections and the storage layer and the containers together in order to move things around seamlessly between different hosts. So yeah, I'd say that's sort of the genesis of Flocker. And when we built Flocker, we decided to build it from the ground up, based on the learning that we'd had from the previous platform. So Flocker actually does a lot less than our previous technology did. It doesn't have built-in high availability, for example, yet. Mm-hmm. It doesn't automatically move things around, but it may well do that one day. And in the meantime, it already solves, I think, a useful problem that an administrator might want to say, okay, I want to move my database to a larger VM, for example, and I want to do that without any downtime. Right. So I can provision a new VM and change the deployment file and run Flocker deploy, and it will move it there with minimal downtime.
So when Marcus was over at the meetup in Amsterdam in October, one of the questions from the crowd that came up was, and I believe this is an outstanding problem. Mm-hmm. Let's say, typical example, I've got 2 Docker hosts, mm-hmm. And I've got a stateful container running on Docker host A. I'm going to stop it and move all the data using the ZFS, so using Flocker, for example, but it's still got open file handles or something like mm-hmm. this. Is that as big a problem as it seems, or is that because people are doing it the wrong way, if that's happening?
So that comes to that's a really interesting question, and it points out a distinction between the way that we think about migrating things around and the way that you think about migrating things when you're running them in a VM environment. Right. My co-founder Rob actually tells me off for calling it live migration, because it's not truly live migration. What we're doing when we're moving something around is we are, well, I'll describe the way that we did it in the previous platform, because this is sort of what we're working towards with Flocker. So the ideal way that we would move something around would be to pause new incoming requests at the proxy layer, mm-hmm. Allow any in-flight requests to complete to the container, and then shut down the container. Sorry, yeah, and then pause new. I think I said that. Then pause new incoming requests. Yeah. So now all the in-flight requests have completed. You can shut down the container. You can do a ZFS send of just the difference between the most recent snapshot and the very latest snapshot to the other machine, which is typically just a few hundred kilobytes of changes. Yep. And then you can start up the container on the other side and unleash the request at the proxy layer. So you're actually shutting down the application and starting it up again, but because you're holding on to the requests from the consumer's perspective, so like the database client, so the web application or the API server or whatever it is that's interacting with the database, the move is completely seamless. There's just a brief period where requests get slow, but we find that's very acceptable to people.
How are you doing the request buffering? I met a guy at the Docker Global Hack Day event last Thursday who was talking about ZeroMQ in this area. And there's also another tool that got mentioned in the October meetup. It's called something pause or TCP something. And I've been Googling like a madman and I cannot find it.
I'd love to know about those things. Okay. I know about ZeroMQ, but I've never heard about the TCP pause thing, but it sounds interesting. So the way we did it in the previous platform was we built our own proxy layer that we called Awesome Proxy. The Awesome Proxy, I actually built the first version of Awesome Proxy around the time that I was working at TweetDeck. So that's just sort of the history of it. But
Hmm.
the idea with Awesome Proxy was that you should be able to treat your cluster like one big computer. You should be able to send any request to any machine and have it reverse proxy to the right place.
Yeah.
And so you could have two machines, and you could send an HTTP request to either of them, and it would Awesome Proxy was sort of a layer 7 proxy, and it would inspect the host header, for example, in HTTP, and proxy things to the right backend container based on the mapping that was given to it of which containers are running on which machines. And the other thing that Awesome Proxy did was it had an API itself that would make it possible to coordinate that migration with the control system that's handling both the proxy layer and the storage layer and the containers at the same time. And so Awesome Proxy was a userland proxy. The way that you pause an incoming TCP connection is that you just don't respond to it until you're ready to.
Right. Okay.
So you can accept the connection, and then you just don't send any bytes until whatever's happened has happened, and then you unblock it, and then you join up the connections. So it's like a reverse proxy, basically.
Okay.
It's easy in userland. It's trickier in the kernel.
Right. That's way outside my area of knowledge, so I'm just going to
Sure.
take your word for it.
Okay.
You mentioned treating a cluster as if it were one machine,
Mhm.
or providing an abstraction layer, which comes very close to the goals of various projects at the moment, such as Mesos.
Mhm.
What I'm interested in is when you're working on Flocker or other ClusterHQ tools, how conscious are you of trying to avoid other people's space or invade other people's space? I.e., how much are you really trying to build this as a tool that'll stand on its own, and how much is it really for internal use?
So that's a really good question. We're very conscious of the other players in the space, and we're not sort of taking an aggressive approach to the ecosystem. In fact, quite the opposite. So one of the things that you'll see in an announcement coming up soon is that we have adopted the FIG format for our application manifest, because we're really interested in interoperability. And another thing that you may see coming out later is that we're going to be working to run Flocker on top of other scale.
Hello? Sorry, I just momentarily lost you there.
Yeah, no, that's fine. I had a little glitch as well, but I was just saying, we're looking sort of in the medium term to integrate with other schedulers. And so Mesos is a scheduler, CoreOS is Fleet, is arguably a scheduler, and there are some others that are interesting as well. And so what we'd love to do is to enable stateful applications in a wide range of different Docker environments. If we can sort of live up to our tagline of being the data people for Docker, then that would be a great place to be. And so the interesting challenge at the moment is that none of these schedulers right now have the right primitives to deal with stateful applications. They don't have the concept in them of move this from one place to another and make sure that there are hooks that we can hook into to control the volume migration as necessary. So what we're having to do is what we call just enough orchestration in order to demonstrate the features that we have, and then hopefully encourage other orchestration frameworks to say, hey, look what those guys are doing, that's cool. And we're intentionally architecting the production ready version of what we're building so that there's a separate volume manager component to the container management component. And we hope to integrate, because we think we can make the whole sort of Docker ecosystem pie bigger for everyone that way.
Right. Okay. Clear. We're coming almost to the end.
Okay.
So I wanted to end with a sort of more open question. Now, obviously you're working on Flocker, but there are gazillions of tools in the ecosystem right now, and there's a lot that many people know of. What I'm wondering is there a tool that you have your eye on that most people perhaps would not have heard of yet?
It's an interesting question. I'm not exactly sure how many tools people have heard of, but I think I don't know if Weave counts. Um, Weave is a very interesting project from the makers of um, RabbitMQ, and it's sort of an overlay network that allows you to basically get a layer 2 network running between containers across regions. And it can even penetrate I think it can penetrate a NAT network. So you could have something inside a data center that reaches out to some container environment. So you could have some containers inside an enterprise data center that
Yep.
reaches out to a cloud environment, and you could join them up into the same logical L2 network. Um, and I think that's really really interesting for a certain class of network applications. And I think it'll be interesting to see how having some more choice between the sort of Docker model of explicit links between containers, which I strongly believe in as a compelling way of joining containers up,
Hmm.
but also having some choice to take a more traditional approach to having different services just running on the same subnet, basically. So I think that's one to watch.
Great. So Weave is Luke's one to watch. Luke, thank you very much.
No problem.
I was wondering if you could repeat one more time. You said earlier you were hiring. Where should people go for information about that?
Great, thanks. I'm glad you asked. So if you go to our GitHub hiring page, there's github.com/clusterhq/hiring, and we've got 5 different jobs listed, from engineering to infrastructure management, and even in particular, we're looking for a senior sort of developer evangelist in the San Francisco area. So if you know anyone, let us know.
Cool. Okay, Luke Marsden, thank you very much.
Cheers. Thanks very much.